Hello everybody. In this lesson I will discuss parallel lines and the 3 theorems that deal with them. I will also discuss 5 examples. Parallel lines. Straight lines that are the same distance from each other along the whole of their length are called parallel lines. Parallel lines will never meet or intersect. And there you find some examples. When a transversal intersects parallel lines, the angles have some interesting properties. This leads to 3 more theorems. The first theorem on parallel lines states, if AB is parallel to CD, then the alternate angles are equal. And then the abbreviation that you may use in your exam will be alt angles equal, and then we always state which lines are parallel. AB parallel to CD in this case. Now where do we find the alternate angles? They are angle X is equal to angle Y. And our reason, alternate angles AB parallel CD. And then there's another pair of alternate angles, and they are angle D is equal to angle E. There's angle D equal to angle E. And your reason will be alternate angles equal AB parallel to CD. Now this is still the same theorem. If AB is parallel to CD, then the alternate angles are equal. It's just that the sketch is now different. Let's have a look. Again, you find AB parallel to CD, and then there's your transversal. So now we can say that angle X is equal to angle Y. And the reason, alternate angles equal AB parallel to CD. And there's another pair of alternate angles. They are angle D is equal to angle E. And your reason, alternate angles equal AB parallel to CD. Now there's your famous maths toolbox, and we can add to this toolbox now. So when there's parallel lines, the first theorem is that alternate angles are equal. Let's do some examples. Example 1. Solve for x in the diagram. So in the diagram you find that AB is parallel to CD and the green line is the transversal. So can you see that this angle 3x and 120 degrees, they form alternate angles, and therefore you can say 3x is equal to 120 degrees, and your reason, alternate angles equal and AB parallel to CD. You must always add that if it's available. So back to our sum, we want to solve x, so therefore we will divide both sides by 3 and x is equal to 40 degrees. Example 2, solve for y in the diagram. So there you can clearly see that there's 2 parallel lines, KL parallel to MN. And then this angle, the 60 degrees angle, is then the alternate angle to that one. So therefore you can say 2y minus 30 degrees is equal to 60 degrees. And your reason, alternate angles equal since KL is parallel to MN. And then there's a little equation now, and we will solve the equation. So let's let the 30 walk across. 60 plus 30 is 90 degrees, and then solve y means let's get rid of the 2. Divide both sides by 2, and y is equal to 45 degrees. Let's look at the second theorem when we have parallel lines. So the theorem states if AB is parallel to CD, then the corresponding angles are equal. And then the abbreviation that you may use in the paper will be corresponding angles. And always add AB parallel to CD. Now on the left hand side, if you have a look at the sketch there, then you will see that angle X is equal to angle Y, and they are the corresponding angles. And remember, corresponding angles, they have to be on the same side of the transversal, and both of them lie above the parallel lines. On the second sketch, we find that angle D is equal to angle E, and your reason will be corresponding angles equal since AB is parallel to CD. This is still the theorem on corresponding angles are equal. I just want to show you that there's other corresponding angles on that sketch. On the left hand side, you will see that angle J is equal to angle K. Corresponding angles AB parallel to CD. And on the right hand side, you also find that angle F is equal to angle G. And your reason, corresponding angles equal since AB is parallel to CD. Remember, you find corresponding angles, they have to be on the same side of the transversal, and both have to be below the parallel line. So it's either above the parallel line or below. So now in your maths toolbox, there's, when we talk about parallel lines, you have two theorems. The first one was alternate angles equal, and now your second theorem is corresponding angles equal. Let's do some examples. Example 3. Solve for x in the diagram. Now, it's very clear that you've got two parallel lines. There's your transversal, and then 110 degrees and 2x. Can you see they are corresponding angles? Therefore, you can say 2x is equal to 110 degrees, and your reason, corresponding angles equal, and add AB parallel to CD. And then you can solve x by dividing away to both sides. So x is equal to 55 degrees. Then example 4, solve y in the diagram. There you also find corresponding angles. And they are this 70 degrees and y plus 20 degrees. And the theorem says that corresponding angles are equal. So we can write y plus 20 is equal to 70 degrees, and the reason, corresponding angles equal since KL is parallel to MN. And then we solve y, so we end with 70 minus 20 is 50 degrees. Now the third theorem on parallel lines states, if AB is parallel to CD, then the co-interior angles are supplementary. Can you remember, supplementary means they add up to 180 degrees. The abbreviation that you may use in the exam is co-int angles, and then remember they are supplementary, and then AB parallel to CD. So where do we find the co-interior angles? If you look at on the left hand side, then we will say that angle X plus angle Y is equal to 180 degrees. And your reason, co-interior angles supplementary, AB parallel to CD. And you will see that they look different, those two smiley faces, since they are not equal. Remember, they're supplementary. They add up to 180 degrees. And then on the right hand side, your two supplementary angles are angle D plus angle E is equal to 180 degrees. And your reason, co-interior angles supplementary, since AB is parallel to CD. Before we continue, have you subscribed yet? Or you can like this video, and better yet, please tell your friends about my channel. Let's continue. Now this is still the theorem. If AB is parallel to CD, then the co-interior angles are supplementary. It's just that your sketch is now the other way around. So where do we find the co-interior angles on this sketch? We have that angle F plus angle G is equal to 180 degrees. Co-interior angles supplementary, since AB is parallel to CD. And then there's another pair of co-interior angles, and that is J plus K is equal to 180, and your reason, co-interior angles supplementary, since AB is parallel to CD. Now the third reason that you can add in your toolbox will be co-interior angles supplementary. And remember, that only happens when you have parallel lines. Example 5. Solve for x in the diagram. Now can you see we have 3x and 150, and the two of them, they form co-interior angles. So now we can say, remember, they are not equal, they are supplementary. So we say 3x plus 150 is equal to 180 degrees. And your reason, co-interior angles supplementary, since AB is parallel to CD. And then we're going to solve x. 150 walks across. 180 minus 150 is 30 degrees. And then to solve x, divide by 3, and x is 10 degrees. Example 6 on the right. Solve for y in the diagram. So now I think it's very clear. You can see that 60 degrees and y minus 10 degrees, they are the co-interior angles. So just be careful. You have to say y minus 10 plus 60 is 180 degrees. They are supplementary. And your reason, co-interior angles supplementary, since KL is parallel to MN. And then we will solve y. Minus 10 plus 60 is 50. Let the 50 walk across. 180 minus 50, and then y is 130 degrees. Now there is also an easy way to remember the three theorems based on the acronym Maths is Fun. Now look at this. The F means corresponding angles. Now where do we find the corresponding angles? When there's parallel lines, let me make them parallel. There's your transversal. So then this one and that one, or that one and that one. So there's your corresponding angles. The U is for the co-interior angles. And where do we find them? But remember, they are this one plus that one is equal to 180 degrees, since they are supplementary. And then the last of your acronym is the N. That's the alternate angles. And this is where you find the N. So the alternate angles, this angle and that one. And remember, they are equal. In the next lesson, I will discuss typical questions that you can expect in the exam on geometry. Click on the video in the left-hand corner to take you straight to the next video.